నోడల్ ప్లేన్స్ వరకు చెప్పాం. రైట్, నోడల్ ప్లేన్స్ వరకు చెప్పాం. రిమైనింగ్ కాన్సెప్ట్ రా. ఆఫ్టర్ మాలిక్యులర్ అలాగే molecular orbital diagrams. Okay, after molecular orbital diagrams we have molecular orbitals electronic configurations to explain the molecules. Okay nana, while we are going for objective ki వెళ్ళేటప్పుడు మనకు డయాగ్రామ్స్ ఏం అవసరం లేదురా, జస్ట్ హౌ we are getting the answers, that's enough. అది చేస్తే చాలు. ఓకేనా, చూడండి. నెక్స్ట్ we have two types of energies nana. One is called 2s 2p. 2s and 2p mixing is one type of system, and the other one is 2s and 2p non-mixing. Okay, two types of energy levels we have. One is 2s 2p mixing and the other one is 2s 2p non-mixing. 2s 2p mixing is also said to be up to 14 electrons. Up to how many electrons you need to take this particular system? Up to 14 electrons. While coming for the 2s and 2p non-mixing, we can take the molecule which contains electrons more than 14. So we are going to take or we are going to use above 14 electron system as well as up to 14 electron system. అరే ఇది గుర్తుపెట్టుకోవాలి జాగ్రత్తగా. 2s and 2p mixing, 2s and 2p non-mixing. While coming for 2s and 2p mixing, how we are going to observe the molecular orbitals energy? Okay, among all these orbitals, sigma 1s less than, sigma star 1s less than, sigma 2s less than, sigma star 2s less than, pi 2px equal to pi 2py less than, sigma 2pz less than, pi star 2px equal to pi star 2py less than, sigma star 2pz. This is the energy order for molecular orbitals. The molecule contains up to 14 electrons. Okay, well coming for the second system or second one, how we are going to write? That is sigma 1s less than, sigma star 1s less than, sigma 2s less than, sigma star 2s less than, sigma 2pz less than, pi 2px equal to pi 2py less than, pi star 2px equal to pi star 2py less than, sigma star 2pz. Okay, ఓకేనమ్మా. All right. See the next one. So why this particular 2s and 2p mixing is observed? The only reason to explain the magnetic nature of B2 molecule. B2 molecule magnetic nature. To explain that, we introduced 2s and 2p mixing system. Generally we used 2s and 2p non-mixing. So with the help of 2s and 2p non-mixing, you could not explain the paramagnetic nature of B2 molecule. So to explain paramagnetic behavior of B2 molecule, we are going to use 2s and 2p mixing system. Okay, let us see some examples now. So what kind of factors we are going to find with the help of molecular orbital theory? What is that? The first one is stability of the molecule, right? Stability of molecule. So how do we find that? How do we confine the stability of the molecule? If at all the number of bonding electrons are greater than number of anti-bonding electrons, in such a case the molecule is stable, means that can be existed. Okay, the first thing. If at all number of bonding electrons less than or equal to number of anti-bonding electrons, in such a case that molecule is unstable, means that cannot be exist. So not existed. This is the first thing. Okay, Rana? This is the first thing, stability. Okay, then coming for the second one. What is that? Magnetic nature. What is that? Magnetic nature. So magnetic nature means if any molecular orbital contains at least one unpaired electron, such molecule is, if unpaired electrons are present, that is what kind of magnetic? Paramagnetic. If no unpaired electrons, then that becomes no unpaired electrons, that is diamagnetic. Diamagnetic. Write down. While coming for the third important case, we are going to find bond order. What is that? Bond order. The last one. Okay, no? Right. The next one, coming for the bond order. So what is bond order? Bond order ante entama? Number of bonds present between two atoms. Number of bonds between two atoms called bond order. Right? How do we find bond order? The simple formula you can use: bond order equal to 1/2 number of bonding electrons minus number of anti-bonding electrons. number of bonding electrons minus number of anti-bonding electrons. Okay. See example. For example, I have B2 molecule. How I am doing, just you can see that. I am not writing molecular orbital diagram. Okay. Just we are explaining with the help of electronic configuration. What is the atomic number of boron atom? What is the atomic number of boron? 5. For 2 boron atoms? 10. So how many electrons are there? Total number of electrons? 10 electrons. 10 electrons. Total number of electrons? 10 electrons. The 10 electrons is less than 14 or greater than 14? Less than 14. So 10 is less than 14 electrons. So what kind of electronic configuration system can be used? 2s and 2p mixing. 2s and 2p mixing, which is called up to 14 electrons. So what is the electronic, what is the molecular orbital? Orbital's energy order? Sigma 1s less than sigma star 1s less than sigma 2s less than sigma star 2s less than pi 2px equal to pi 2py. This is enough because we have only 10 electrons. As you know that this is 2 electrons, 4, 6, 8, and now we have 2 more electrons are there. According to the Hund's rule, as you know, what is Hund's rule? The equal energy orbitals can be accommodated with each one electron. So you can write pi 2p x1, pi 2p y1. This is the electronic configuration of B2 molecule. What is that? B2 molecule. So now within the B2 molecule, number of bonding electrons. How many we have? This is 2, 4, 5, 6. Number of bonding electrons are 6. Coming for the number of anti-bonding electrons. How many we have, Nana? 2 plus 2, 4 electrons. So as we know that number of bonding electrons are greater than number of anti-bonding electrons. So that is the reason. Is it stable or unstable? Stable, right? It is stable. That is the first thing. Then coming for the second one. Bond order we need to calculate. Bond order means 1 by 2 number of bonding electrons minus number of anti-bonding electrons. Number of anti-bonding electrons. So what how many bonding electrons we have? 6 minus 4. 2 by 2 equal to 1.0. That means in B2 molecule between 2 boron atoms you can find only 1 bond. You can find only 1 bond. Next, coming for magnetic nature. Is it contains unpaired electrons or not? It contains unpaired electrons, right? It contains unpaired electrons. As 2 unpaired electrons are present, it is what kind of magnetic nature? Paramagnetic nature. What is that? Paramagnetic nature. The electron pair is there in pi bonding molecular orbital. Pi bonding molecular orbital. So that is the reason the bond is nothing but pi bond. Which bond this is? Pi bond. Okay. Paramagnetic in nature. So what is the magnetic momentum? Magnetic momentum formula root over n into n plus 2 Bm Bohr magnetons. This is the magnetic momentum formula. So how many electrons we have? 2 unpaired electrons. So 2 into 2 plus 2. Andama. Root 8, right? So this is 2.84 Bm. 2.84 Bm. Right. Okay. Right, next one. The next one. If I have another molecule C2 molecule. So how many number of electrons are there in C2? Total number of electrons? 12. Because 6 plus 6. 12 electrons, is it less than 14 or greater than 14? Less than 14. So total number of electrons equal to, we got 12 electrons, which is less than 14. So we can take S and P mixing, S and P mixing, S and P mixing. Okay, S and P mixing. So S and P mixing means up to 14. So the order sigma 1s less than, sigma star 1s less than, sigma 2s less than, sigma star 2s less than, pi 2px equal to pi 2py less than sigma 2pz. Okay, now write the electronic configuration. We have total number of electrons. How many we have? How many electrons we have? 12 electrons. So this is 2, 4, 6, 8. And we have 4 more electrons. So 1, 1, 9, 10, 11, 12. So you can write 2, 2. Okay. Okay, Rana? So coming for the number of bonding electrons. How many we have? 2, 4, 6, 8. Number of bonding electrons are 8. Number of anti-bonding electrons. 2 plus 2, 4 electrons. As number of bonding electrons are they greater than number of anti-bonding electrons. Is it stable or unstable? Stable. That means the C2 can be existed. C2 can be existed. That's the first one. Then coming for the second case. Second case, coming for the bond order. Bond order equal to, what is the formula we gave? 1 by 2 into NB minus NA. NB minus NA. That means 1 by 2, 8 minus 4, that is 2.0. That means C double bond C we can write. C double bond C. Are remember, Nana? These two bonds are, bond pairs are nothing but pi bonds. Right? Pi bonding molecular orbitals. The two electron pairs are there in pi bonding molecular orbital. So that is the reason whatever the two bonds are present between the two carbon atoms within the C2 molecule, the two bonds are pi bonds only. Sigma bonds are how many? How many sigma bonds? Sigma bonds are 0. Sigma bonds are 0. The two bonds are pi bonds only, because the two bond pair of electrons are present in pi bonding molecular orbital. Coming for the magnetic nature. Do we have any unpaired electrons? So magnetic nature is diamagnetic, because there is no unpaired electrons. There are no unpaired electrons. Write down. Okay. Then coming for the next one, O2 molecule. Third example. Third example, O2 molecule. O2 molecule. So what is the atomic number of oxygen? 8. So for 2 oxygens, 16. So total number of electrons are 16 electrons, right? So 16 is greater than 14. So you can take 2s and 2p non-mixing. 2s and 2p non-mixing you need to take. Okay, no? 2s and 2p non-mixing. Then what is the order of molecular orbitals? Sigma 1s less than sigma star 1s less than sigma 2s. Sigma 2s less than sigma star 2s. But there is a change you can find. What is that? Sigma 2pz come first, then pi 2px, pi 2py come later. Pi 2px equal to pi 2py. Okay, no? Then less than pi star 2px equal to pi star 2py is less than sigma star 2pz. This is the molecular orbital order. Molecular orbitals order. Then how many electrons we have? Total number of electrons? 16 electrons. So you can accommodate 2, 4, 6, 8, 10, 12, 14. This is 15, 16 according to the Hund's rule. Okay, no? So coming for the number of bonding electrons, we need to calculate 2, 4, 6, 8, 10, 11, sorry, 10 only. Okay. Number of bonding electrons 10. Number of anti-bonding electrons 2, 4, 5, 6. 5, 6. So number of anti-bonding electrons are 6. As you know that number of bonding electrons are greater than number of anti-bonding electrons. So that is the reason the molecule is existed. Coming for the bond order. What is the formula of bond order? Half into number of bonding electrons minus number of anti-bonding electrons. You can find 2.0. That means you can find O double bond O. O double bond O. చూడండి ఒకసారి జాగ్రత్త వింటే దిస్ ఈజ్ bond pair present in sigma bond. Okay. One bond pair is present in pi bond because 4 electrons minus 2 electrons means 2 electrons are there. So that is the reason one is sigma bond and one is pi bond. One is sigma bond and one is pi bond between 2 oxygen atoms in O2 molecule. Okay. The next one, magnetic nature. Is it contains unpaired electron or not? Yes, 2 unpaired electrons are present. 2 unpaired electrons present. So that is the reason it is paramagnetic. And its dipole moment, that is, sorry, magnetic momentum, same 2.84 bm. Root over n into n plus 2, as we did already. Okay, na? Write down. Okay, na? Is the next one. ఇదంతా మనం రాసి చేయాల్సిన అవసరం లేదురా. వీ హ్యావ్ సమ్ షార్ట్ కట్. దీనికి ఒక చిన్న షార్ట్ కట్ ఉంది, అది ఎలా చూడండి ఒకసారి జాగ్రత్తగా వినండి. హౌ వీఆర్ డూయింగ్ ద క్వశ్చన్స్. వాడు ఎలా అడుగుతాడంటే Which of the following molecule contains bond order equal to 2.0? You can ask like that. Or the bond order of Cn minus, you can give like that. Questions ala istadu. Ala ichcheటప్పుడు em cheyalante, we have shortcut. What is that? See, first you have a better idea related with nitrogen molecule. We can write N triple bond N, right? The number of bonds present between two nitrogen atoms are equal to 3 bonds. How many bonds? 3 bonds. So we can write N triple bond N. Okay. So total number of electrons, how many electrons it has? 14. So you can write total number of electrons 14. Here you can write total number of electrons, number of bonding electrons, number of anti-bonding electrons. The last part is bond order. 3 parts we are writing. If 14 electrons are there, then how many bonding electrons should be there in the molecule? 10 electrons. Number of anti-bonding electrons 4. Bond order is absolutely 3.0. If you decrease the number of electrons by 1 unit or increase the number of electrons by 1 unit, the bond order can be decreased by 0.5 units. If you decrease the total number of electrons, means goes up 13, 12, you can go like that. If you increase the number of electrons, means you can come down like 15, 16, 17, 18, like that. You can minimize or you can subtract the bond order from it exactly 0.5. 0.5 మనం సబ్స్ట్రాక్ట్ చేసేయాలి ప్రతి సింగిల్ యూనిట్కి. ఓకేనా? సో నౌ ఇఫ్ యూ గో అప్ పైకి వెళ్ళామనుకున్నానా, ద నెంబర్ ఆఫ్ యాంటీ బాండింగ్ ఎలక్ట్రాన్స్ ఆర్ కాన్స్టెంట్. మీన్స్ ఇఫ్ యూ డిక్రీజ్ ద నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్. ఇఫ్ ఐ కమింగ్ డౌన్ కిందకు వచ్చామనుకోండిరా, దట్ మీన్స్ ఇఫ్ యూ ఇంక్రీజ్ ద నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్, దెన్ a number of bonding electrons remains constant. Okay. For example, I am writing 13. This is constant, means 4. 13 minus 4, 9. The bond order can be decreased by 0.5, so 2.5. Okay. Then coming for 12. Then this is 4, remains constant. 12 minus 4 equal to 8. The bond order becomes 0.5 decreases, 2.0. Then now coming for 11, this is 4, remains constant, 7, this is 1.5, this is 10, this is 4, this is 6, 1.0, this is 9, this is 5, sorry 4, this is 5, this is 0.5, 8 electrons, 8 electrons means 4, 4, 0.0. I am not writing less than 8, because up to 8 electrons you can write the electronic configuration, because as you know that sigma 1s less than, sigma star 1s less than, sigma 2s less than, sigma star 2s. So you can write the electronic configuration. If it is more than that, it is difficult to write. It takes more time. So you can simply do this. Then let me increase the number of electrons. If 15 electrons are there, then this will be constant, 10. So 15 minus 10 equal to 5. The bond order decreases, 2.5. Then coming for 16, this is 10, this is 6, this is 2.0. 17, 10, 7, 1.5. 18, 10, 8, 1.0. 19, 10, 9, 0.5. Coming for the 20, 10, 10, this is 0.0. In such a way you can remember. Then remember, 10 electrons, 16 electrons you can make round. You can make round. Remember, all even number, exception is 10 and 16. 10 and 16 are exceptional exceptional number. Generally diamagnetic. What is that? Diamagnetic. Except 10 and 16, all even number are diamagnetic. All odd number of electrons are paramagnetic, because it contains at least one unpaired electron. Then based on this data, how do I solve the questions? See, for example, I need to find Cn minus. What I need to find? Cn minus. C naught. The carbon atomic number 6, nitrogen atomic number 7, Minus means you are adding 1 electron. 6 plus 7 plus 1 equal to 14. The 14 is bond order 3.0. Bond order 3.0. Number of bonding electrons 10. Number of anti-bonding electrons 4. Number of bonding electrons 10. Number of anti-bonding electrons 4. Is it paramagnetic or diamagnetic? Obviously diamagnetic. In even number only 10 and 16 are paramagnetic. Remaining all even number are diamagnetic. So this is diamagnetic. Did you get this, Nana? Everyone? In such a way, so the same example, let me have CO plus I have. CO plus. Carbon atomic number 6. Oxygen atomic number 8. Minus 1. 6 plus 8, 14 minus 1, 13. 13 means bond order. As we wrote there, 2.5. Is it a diamagnetic or paramagnetic? Paramagnetic, because it is odd number, right? So magnetic nature, paramagnetic nature. Got it, Nana? Everyone? In the same way, for example, I have F2 minus. Fluorine, 9 into 2, 18, plus 1, 19. 19 electrons. 19 electrons means bond order 0.5. 0.5. Then magnetic nature, odd number, paramagnetic. Paramagnetic. All questions are there. Okay, na? Right. I will give some questions, you can solve them. Make it fast. Chapam. Okay, sure. అరే నాన్న ఒకసారి ఆ ఫ్యాన్ ఆన్ చేయండి రా. రే బాబు ఫ్యాన్ ఆన్ చేశారు. మీరంతా ఏ కాలేజీరా? నారాయణ ఎక్కడ? సంతోష్ దగ్గర? అదేలే సంతోష్. నువ్వు కూడానా? నువ్వమ్మాయి? ఎన్ఆర్ఐ ఎక్కడా? కౌసల్యగా. రాసిన ఒక క్వశ్చన్ చెప్తారా ఏంట్రా? ఒక క్వశ్చన్ చెప్తారా అండి? రైట్ డౌన్ క్వశ్చన్ కంప్లీట్ చేస్తారా? రాస్తారా? రాసినాక రాయండి అమ్మా క్వశ్చన్. N2 and O2. N2 and O2. N2 nitrogen రా. N2 and O2. O2 forms unipositive ions. Then their bond order and magnetic property. Bond order and magnetic property affected question mark అంటే ఎలా ఎఫెక్ట్ అవుతుందో రాయాలి. N2 and O2 forms unipositive ions. Then how does the bond order and magnetic properties have been changed? ఎలా చేంజ్ అయ్యాయని అడుగుతాడు. చెప్పండి. Can you solve this question? చెప్పండి. What will be the answer? Sira. N2 turns into unipositive, means N2 turns into N2 plus, right? O2, dioxygen turns into O2 plus, right? So coming for the number of electrons, how many electrons we have? 14 electrons. The 14 electrons turns into 13 electrons. Coming for the bond order is 3.0, here 2.5. Magnetic property, initially diamagnetic, this is paramagnetic, contains only 1 unpaired electron. Okay na? So mu equal to 1.73 bm Bohr magnetons, 1.73 bm, because it contains only 1 unpaired electrons, only 1 unpaired electron. While coming for the O2, how many electrons initially we have? 16. This becomes 15. For 16 the bond order 2.0. For 15 2.5, above 16 2.5. The magnetic nature, this is also paramagnetic, this is also paramagnetic, but here the magnetic momentum is 2.84, because number of unpaired electrons are 2, but in this case number of unpaired electrons only 1, so 1.73 bm. Number of unpaired electrons only 1 we have. అర్థమైందా? ఎలా అడిగేయమంటాడంటే స్టేట్మెంట్ టైప్లో అడుగుతాడు. ఎలాగనిసి అంటే ద స్టేట్మెంట్ 1, while N2 turns into N2 plus, the bond order decreases. The bond order decreases, right or wrong? While N2 turns into N2 plus, the bond order decreases. Correct statement. Okay. Then the second one, the magnetic nature remains constant while N2 turns into N2 plus. False statement or incorrect statement. Okay. Then while conversion of O2 into O2 plus, the magnetic property increases. The magnetic property increases. False, because decreases 1.73. ఇలా అడుగుతాడు statements, right? These are actually chemical bonding లో మనకి ఫైనల్ ఎగ్జామ్లో అడిగే క్వశ్చన్స్ అన్ని స్టేట్మెంట్ అయితే మ్యాక్సిమం నెంబర్ ఆఫ్ క్వశ్చన్స్. సో నీకు ఆ కాన్సెప్ట్ తెలిస్తేనే స్టేట్మెంట్ రాంగ్గా రైట్ అనేది చెప్పొచ్చు ఈజీగా. ఓకేనా? ఇది రాసాక నెక్స్ట్ ఇంకో క్వశ్చన్ చెప్తారా అంటారు. Next question. Arrange the following species. Arrange the following species. Arrange the following species. Bracket lo H2, comma arrange H2, comma H2 plus comma H2 minus in increasing order of their stability, increasing order of their stability, Can anyone solve this question? Arrange H2 plus H2 minus species increasing order of their stability. Which is more stable? H2 more stable. Why? Two electrons, that is another thing, and another concept, bond order equal to 1.0. Then coming for H2 plus and H2 minus. H2 minus. Why? Can you say which option is correct? H2 greater than H2 plus equal to H2 minus. Second one, H2 greater than H2 plus greater than H2 minus. Third option, H2 greater than H2 minus greater than H2 plus. Fourth option, H2 minus greater than H2 minus greater than H2 minus greater than H2 plus greater than H2. Fourth option. Inga. The option ra. Third option. Okay. Miru. Fourth option. Fourth. Second option. మరి కొంతమంది ఫస్ట్ ఆప్షన్ చెప్పండి, 4 అయిపోతుంది. చూస్ ద కరెక్ట్ ఆన్సర్ అని మళ్ళీ నాకు క్వశ్చన్ ఇవ్వండి, నేను చేసుకుంటా. అంతే కదరా? హూ టోల్డ్ కరెక్ట్ ఆన్సర్ అని నాకు క్వశ్చన్ ఇవ్వండి, మళ్ళీ నేను అప్పుడు చూస్ చేసుకుంటా. వీడు చెప్పాడు, వాడు చెప్పాడు, ఆవిడ చెప్పాడు. చూడమ్మా, ఫస్ట్ థింగ్ ఏంటంటే H2 మీన్స్ ద ఎలక్ట్రానిక్ కన్ఫిగరేషన్ యూ ఆర్ గోయింగ్ టు రైట్ sigma 1s2. So coming for the bond order, number of bonding electrons 2 minus number of anti-bonding electrons 0, 1.0. Okay. While coming for the H2 plus, we have only one electron, so that we can write sigma 1s1. Sigma 1s1. Coming for the bond order, 1 by 2 into 1 equal to 0.5. Then coming for the third one, H2 minus, sigma 1s2, sigma star 1s1, sigma star 1s1. Okay, sigma 1s2, sigma star 1s1. Coming for the bond order equal to 1 by 2, 2 minus 1 equal to 0.5. 2 minus 1 equal to 0.5. Okay. So see, as usual, చూడండి ఒకసారి, when compared to the fractional bond order, the bond order with an integer is always more stable. కాబట్టి ఏమైందంటే స్టెబిలిటీ H2 greater than H2 plus equal to H2 minus, because bond orders are equal. అలా రాస్తారు, రాయొద్దు, అదే మీరు చేసే తప్పు. H2 plus greater than H2 minus, H2 plus greater than H2 minus. Why we are going to write like this? The only reason, H2 plus H2 minus contains one anti-bonding molecular orbital and electron in anti-bonding molecular orbitals. As you know that stability is inversely proportional to anti-bonding electrons. If even one electron is there, that can give less stable, that can bring less stable. So the correct option is, sorry, this was not, second option is the correct answer. Second option is the correct answer. అర్థమైందా రీజన్? when compared to the fractional bond order, Bond order with an integer is more stable. The next, the stability is inversely proportional to number of anti-bonding electrons. ఓకేనా? అలాగే Li2 Li plus Li2 plus Li2 minus same order. Instead of hydrogen he can give lithium. Li2 greater than Li2 plus greater than Li2 minus. అక్కడ సేమ్ ఆర్డర్. ఓకేనా? రైట్. చూడండి నెక్స్ట్ మోడల్ క్వశ్చన్ ఎలా అడుగుతాడో చూడండి ఒకసారి. బేస్డ్ ఆన్ VBT అండ్ MOT అన్నింటి కలిపి అడుగుతున్నా క్వశ్చన్ చూడండి. నెక్స్ట్ క్వశ్చన్, విచ్ ఆఫ్ ద ఫాలోయింగ్ overlapping gives positive overlapping. Positive overlapping. Positive overlapping. చూడరా, Px plus minus minus plus Px. Second one, Px plus minus Py plus minus Px plus minus Px plus minus. Fourth one, S plus minus Py plus minus. Which will be the correct answer? చూడండి ఒకసారి కాన్సెప్ట్ వినండి. ఎప్పుడైనా దాన్ని బట్టి ఆన్సర్ తర్వాత చేసుకోవచ్చు. చూడమ్మా, ఓవర్లాపింగ్లో we have positive overlapping, negative overlapping and zero overlapping. Positive overlapping, negative overlapping and zero overlapping. If you take s orbital తీసుకుంటే it is always forms what kind of bonds? Always forms sigma bonds. Means end to end overlapping along the axis. అంటే this is s orbital, this is p orbital, that is pz orbital. The signs must be uniform, plus minus minus. Plus plus part can give, what is that? Positive overlapping. S orbital. Okay. While coming for the px, py, pz orbital, pz orbitals are always going to involving in sigma bonding along the axis. So coming for the p orbitals, that is pz only forms sigma bond. That means along the axis. This is a z axis. Okay. This is plus minus. This is again plus minus. Plus minus. Pz orbital. This is another pz orbital. Okay, Rama? This is the formation of sigma bond. The px and py orbitals are going to form which bonds? Lateral overlapping. Lateral overlapping means pi bond. So perpendicular to the internuclear axis. Perpendicular to the internuclear axis. That means this may be px or may be py, anything. This is plus minus, plus minus. This may be px or may be py. This may be px or may be py, resulting in the formation of pi bond. If both parts are similar charges, plus plus, plus plus, plus plus, this kind of overlapping is representing a positive overlapping. What is that? Positive overlapping. Okay? Positive overlapping. If the signs are different, that is going to give negative overlapping. That is going to give negative overlapping. So that means if I am going to write like this, this is s orbital plus minus. Okay, Rana? This is p orbital minus plus. First combination s 2pz. Okay, and another combination. This is pz plus minus. This is pz minus plus. pz pz. Okay, Rama? pz pz. And finally coming for the third one. This is px or py plus minus minus plus. This is called negative overlapping. What is that? Negative overlapping. Okay, na? Negative overlapping. Positive overlapping one. If the signs are identical, either plus plus or minus minus can bring positive overlapping. Plus minus or minus plus can bring negative overlapping. Then coming for zero overlapping. Zero overlapping means s orbital never going to form pi bond. If I am writing s orbital with the combination of px or py, px and py generally forms pi bond. So s orbital never going to form pi bond. So this is a zero overlapping. This is zero overlapping. This is pz orbital. This is px or py. Px or py. This is along the axis. This is a perpendicular to the axis. Can it give any overlapping? No. These two are zero overlapping. What kind of combination? Zero overlapping. Okay, na? So now what will be the answer for the question? C. Right. Ardena? Okay, na? ఆ సైన్స్ కరెక్ట్గా పెట్టాలి, ప్లస్లు మైనస్. Why s orbital? The combination is going to give zero overlapping because s orbital never forms pi bond. Pz orbital never forms. Pz orbital never forms for pi bond. ఇది pz. If the two orbitals are lying on same axis or perpendicular to the axis, then only the bond formation is observed. If both are present in opposite axis, then there is no overlapping. Next concept amma, Fazan's rules. Subheading Fazan's rules. Fazan's rules. Fazan's rules. Fazan's rules. Fazan's rules. So what is the main use of Fazan's rules? Fazan's rules main use ఏంటంటే, if you take an ionic compound, ఒక ionic compound తీసుకున్నాం, the ionic compound still contains some percentage of covalent character. That means there is no ionic compound is 100% ionic. ఏ ionic compound తీసుకున్నా అది 100% ionic characterతో ఎప్పుడూ ఉండదు. But there may be chance of a compound with 100% covalent, the bond which is formed between two identical atoms, as we discussed already, like hydrogen H2, N2, O2, F2, these are all 100% covalent. But while coming for the ionic compounds, the ionic compounds are never going to considered as 100% ionic in nature. Each of the ionic compound contains certain percentage of covalent character. So to explain the covalent nature of an ionic compound, we are going to use Fazan's rules. Write down. First point. To explain covalent character in ionic compound, Fazan's rules are used. Fazan's rules are used. ఒకసారి చూడండి, how we are going to find the covalent character within the ionic compound. Ionic compound means you can find the complete transfer of electron from one atom to another atom. You can find complete transfer of electron from one atom to another atom. That is called absolute ionic compound. Ionic character అంటే ఏంటంటే సింపుల్గా, if you take one ionic compound, there must be transfer of one electron from one atom to another atom, as we discussed already. If I am taking NaCl, the electron is transferred from sodium to chlorine. If the electron transfer is decreases means instead of losing electron, the metal atom again mutually shares the electron, then that is going to diminish ionic character and enhance covalent character. అర్థమవుతుందా? So what is ionic character? Ionic character అంటే ఏంటన్నా? Ionic character means complete transfer of electron. ఎవరికి? Transfer of electron from a metal atom to non-metal atom. That is ionic character. Covalent character means? Yes, covalent character means mutual sharing. What is that? Mutual sharing of electrons. Mutual sharing of electrons. That is covalent character. Mutual sharing of electrons. This is ionic character means complete transfer of electron. Complete transfer of electron. Now see, what is Fazan's rule? Fazan's rule ఏంటంటే జాగ్రత్త వినండి అన్న. For example, I am taking lithium iodide. What I am taking? Lithium iodide. See properly. The lithium size of cation is very small, small in size. The I minus size is large anion. I minus size is large anion. Okay. Now see properly. If there is no influence of the lithium plus on the I minus anion, the electron cloud around the I minus is symmetrical, like a sphere you can find. I minus చుట్టూ ఉండే ఎలక్ట్రాన్ క్లౌడ్ ఎలా ఉండాలమ్మా? సిమ్మెట్రికల్గా ఉండాలి, లైక్ ఏ బాల్. ఎప్పుడు? వెన్ దెర్ ఇస్ నో ఇన్ఫ్లుయెన్స్ ఆఫ్ lithium plus nucleus. When there is no influence of lithium plus nucleus, the electron cloud around the I minus is symmetrical, like a ball we can find. But as we know that lithium plus size is small, as the ion size is small, then what will happen? The nuclear charge is more. So under the influence of lithium plus, then what will happen? The I minus electron cloud partially distorted towards the lithium plus nucleus. Lithium plus nucleus means the symmetric electron cloud around the I minus becomes asymmetric. Becomes asymmetric. That kind of phenomenon is called polarization. What is that? Polarization. Due to the polarization, complete transfer of electron increases or decreases? Decreases, because mutual sharing increases. The mutual sharing increases indicating that the covalent character increasing. Covalent character increasing. మళ్ళీ చెప్తున్నా చూడండి. Within the ionic compound, generally we can expect ionic bond. If at all the cation size is small, anion size is large, then what will happen? Under the influence of cation, the anion electron cloud becomes asymmetric. The symmetric electron cloud around the I minus becomes asymmetric. Okay now? That kind of phenomenon is called polarization. What is that? Polarization. దాన్ని ఏమంటాం? Polarization అనేసి అంటాం. Polarization. Okay. Due to the polarization అవడం వల్ల ఏమవుతుందమ్మా? Due to the polarization, what will be decreased? Ionic character decreases, covalent character increases. Covalent character increases. Polarization వల్ల covalent character increase అవుతుంది. ఓకేనా? Covalent character develops, ionic character decreases. Polarization means, polarization అంటే ఏం చెప్పా? The asymmetric electronic cloud. Asymmetric electronic cloud around anion by the influence of ఎవరి ఇన్ఫ్లుయెన్స్ ఉండదు? మీదే నాదా? ఎవరిదిరా? By the influence of metal ion means cation. That is called polarization. Now you can see, if I am taking different cations, can they have same tendency to get polarization? No, not at all. Whatever the tendency of cation is there, that is called polarizing power. What can we say? Polarizing power. Cation kunde tendency ఏమంటాం? Polarizing power. The anion has different tendency to get polarization is called polarizability. What is that? Polarizability. Okay. Polarizability, polarizing power. PP means polarizing power. Polarizing power. This is for cation. This is for anion. Okay. Polarizing power equal to formula charge by radius square. Radius square. Polarizing power. If polarizing power of a cation increases, polarization increases. If polarizability of anion increases, again polarization increases. If a polarizing power of a cation or polarizability of an anion increases, can increase. Which character? Covalent or ionic? Covalent character. Can decrease ionic character. So we can write polarizing power of cation or polarizability of anion is directly proportional to covalent character and inversely proportional to ionic character. Ionic character. రాసుకోండి. మా నెక్స్ట్ అవడింగ్రా ఫ్యాక్టర్స్ ఎఫెక్టింగ్ ఓకే. ఫ్యాక్టర్స్ ఎఫెక్టింగ్ first this side polarizing power of cation, this side polarizability of anion. So the first one is size. First factor is size. As size increases for cations, nuclear charge decreases, polarizing power decreases. Ante kada? So that is the reason size is inversely proportional to polarizing power of cation. Okay na? Polarizing power of cation. See na? If I have the cations like lithium plus, sodium plus, potassium plus, cesium plus. Which has more polarizing power? Lithium plus greater than Na plus greater than K plus greater than Cs plus. Now let me have ionic compounds like LiCl, NaCl, KCl, CsCl. Which has more covalent character? Which has more covalent character? Which has more covalent character? LiCl, because covalent character is directly proportional to polarizing power of cation. Which has more polarizing power? Lithium plus. So covalent character is more for LiCl than NaCl, than KCl, than CsCl. Which is more ionic? CsCl. Which is more ionic? CsCl. Ionic character అడగదనుకోండి reverse order. LiCl less than, NaCl less than, KCl less than, CsCl. Okay, Nana? This is the first one. Polarizing power. While coming for the anions, as the size increases, nuclear charge decreases. So easily loses electrons. So polarizability of anion is directly proportional or inversely proportional to size? Directly, because I took I minus, large size. So directly proportional to size. Directly proportional to size. Now coming for polarizability order, F minus, Cl minus, Br minus, I minus. Which has more? Which has more? I minus has more. So F minus less than, Cl minus less than, Br minus less than, I minus. Okay, Rana? Now coming for the covalent character. Let me have NaF, NaCl, NaBr, NaI. Which has more covalent character? NaI. Ionic character? NaF greater than, so on, NaI. The first factor. Okay. Then coming for the second one, Nana. Charge. Yeah, charge of cation increases, nuclear charge increases. Nuclear charge is directly proportional to polarizing power of cation. Kabatti the polarizing power of cation is directly proportional to charge. Directly proportional to charge. So if you have polarizing power like Na plus, Mg plus 2, Al plus 3. Which has more? Al plus 3. Covalent character. NaCl, MgCl2, AlCl3. Which has more? AlCl3. NaCl, MgCl2 plus than AlCl3. Well, coming for this case, polarizability of anion. As negative charge increases, size increases. Polarizability also increases. So also directly proportional to charge. Also directly proportional to charge. So example for polarizability, if I have Cl minus S minus 2, S minus 2, P minus 3. Which has more? Which has more polarizability? P minus 3. Alright, directly proportional to charge. Okay. Cl minus less than, S minus 2 less than, P minus 3. So covalent character, which has more? NaCl, Na2S, Na3P. Sodium phosphide. Na3P has more covalent character. If you need to find ionic character, NaCl is more. Right. వాళ్ళు అడిగేటప్పుడు కూడా క్వశ్చన్స్ అలా అడుగుతారు. విచ్ ఆఫ్ ద ఫాలోయింగ్ ఈజ్ మోర్ అయానిక్, విచ్ ఆఫ్ ద ఫాలోయింగ్ ఈజ్ మోర్ కోవలెంట్. యూ నీడ్ టు కన్సిడర్ ద టూ కేసెస్. Okay na? Right, last factor, electronic configuration. Electronic configurations. Avula? Let's see, electronic configuration. Inert gas configuration is there for any metal atom. Inert gas configuration, that is generally ionic in nature. Pseudo inert gas, what is that? Pseudo inert gas configuration, that is generally covalent in nature. What kind of nature it has? Covalent in nature. Like NaCl I am taking. NaCl contains Na plus, right? Which is similar to that of neon electronic configuration. So it is ionic. While let me take ZnCl2, zinc chloride nana, Zn plus 2 we have, it is not inert gas configuration. It has the configuration as argon 3d10. Argon 3d10. The 3d10 indicates. 3d10 indicates. Yes. Inert gas, that means complete configuration or fulfilled electronic configuration, which is not inert gas. Which is not inert gas. That kind of thing is called pseudo inert gas. If you compare zinc chloride with NaCl, zinc chloride is covalent in nature, NaCl is ionic in nature. Or zinc chloride has more covalent nature than NaCl. NaCl has more ionic nature than zinc chloride. Okay, write down. The last concept we have, that is dipole moment. Okay. Next one, dipole moment, subheading. Dipole moment. Dipole moment. Dipole moment. Can anyone say what is dipole moment? What is dipole moment? We have generally two types of covalent bonds. One is polar and other one is non-polar covalent bond, as we described already. Two covalent bonds we have, Nana. One is non-polar covalent bond and the other one is polar covalent bond. Non-polar covalent bond means if the electronegativity difference is very less or zero, in such a case the bond pair is exactly present between the two atoms, exactly half of them, bond length. Means exactly center of the internuclear axis. Exactly center of the internuclear axis. While coming for the polar covalent bond means, let me take two different atoms like hydrogen and chlorine. This is the covalent bond. The electron pair is closely towards the highly electronegative atom. Closely towards the highly electronegative atom and far away from the less electronegative atom. So, if the bond pair is exactly present between the center of the two atoms is called non-polar. If the bond is present exactly one direction or one side of the bonded atom is called polar covalent bond. See, if it is non-polar, non-polar means we could not find any charges. While in the case of polar, we can find charges because as the electronegativity of chlorine is greater than hydrogen, okay, Rana? This pair of electrons are strongly attracted towards the chlorine. So that is the reason the chlorine will acquire partially negative charge, hydrogen will acquire partial positive charge. The partial positive negative denotes with delta sign. Dento denote chestunna, delta sign to denote chestunna. This is partially negative delta minus, this is partially positive delta plus we are writing. Okay. This kind of thing, if at all we are going to find in any molecule, that kind of portion is called dipole. What is that? Dipole. As two oppositely charges are present within a given molecule or covalent molecule, in such a case what will happen? There must be certain moment is present within that dipoles, within the dipoles. So that is nothing but dipole moment. The dipole moment is denotes with mu. Mu is nothing but the product of charge into distance of separation which is perpendicular. Distance of separation which is perpendicular, because this is positive sphere, right? This is a negative sphere. Between these two, whatever the distance we are finding, that is absolutely perpendicular distance. What is that? Perpendicular distance. So dipole moment is nothing but the product of charge and distance of separation which is perpendicular. So what will be the units? How do we write the units, Nana? Units is nothing but, charge means coulombs, right? Coulombs. We can write coulomb meters. Coulomb meters or coulomb meter. In generally we can represent with capital C, capital M. It's not centimeter or not chief minister. Coulomb. Coulomb meter. Coulomb meters. See, otherwise we are going to denote with debye. Other units are debye. 1 debye equal to 3.33 into 10 power minus 30 coulomb meters. This is interconversion. I can change this. Right. And another important thing, okay, dipole moment is what kind of factor? It is actually vector quantity. What kind of property it is? Vector quantity. Vector quantity means you are going to denote a sign with this. This indicates, the head indicates high electronegative part, the tail indicates low electronegativity part. That means in the case of HCl, how can I write? The sign convention, how can I write? I need to write head towards the chlorine, tail towards the hydrogen. Okay, no? It is always vector quantity. Right, work. Right, తొందరగా. Next, awarding applications of dipole moment. Applications of dipole moment. అరే చార్జెస్ ఫార్మింగ్ అనేది అయానిక్ క్యారెక్టరే కదా, అంటే డైపోల్ మూమెంట్ని బేస్ చేసుకుని ఏం చెప్పొచ్చు, ద పర్సంటేజ్ ఆఫ్ అయానిక్ క్యారెక్టర్ ప్రజెంట్ ఇన్ ఏ కోవలెంట్ కాంపౌండ్. ద పర్సంటేజ్ ఆఫ్ కోవలెంట్ క్యారెక్టర్ ఇన్ అయానిక్ కాంపౌండ్ కెన్ బి ఎక్స్ప్లెయిన్డ్ విత్ ద హెల్ప్ ఆఫ్ Fajans rules. The percentage of ionic character present in a covalent compound can be explained with the help of dipole moment. అర్థమవుతుందా? చార్జెస్ ఫామ్ అవడం అనేది దేని కాన్సెప్ట్, అయానిక్ బాండ్ కాన్సెప్ట్. సో అప్లికేషన్స్ నాన్న, ద ఫస్ట్ వన్ ఈజ్ పొలారిటీ ఆఫ్ ద మాలిక్యూల్స్ కెన్ బి ఫైండ్. ఫస్ట్ పాయింట్ పెట్టుకోండి, పొలారిటీ. పొలారిటీ ఆఫ్ మాలిక్యూల్స్ కెన్ బి ఫైండ్. Polarity of molecules can be found. Okay, so how can we find? See now, first one, if dipole moment mu equal to 0, if dipole moment mu equal to 0, such molecule is non-polar. What kind of molecule? Non-polar. Okay, if dipole moment mu is not equal to 0, such molecule is polar molecule. What kind of molecule? Polar molecule. So what kind of molecules are polar and what kind of molecules are non-polar? How do we say? First condition చూడరా, for non-polar molecules ke molecules nantamante the regular geometry molecules, non-polar means mu equal to 0. చూసుకోండి ఒకసారి కాన్సెప్ట్. ఆల్ లీనియర్ ప్లెనార్ అండ్ రెగ్యులర్ జామెట్రీ with identical atoms, dipole moment is 0. With identical atoms, dipole moment is 0. ఏమేమి ఉండాలి కండిషన్? The molecule may be linear, the molecule may be planar, that may be trigonal planar or square planar, any planar molecule, and regular geometry means regular tetrahedral or regular octahedral or regular trigonal bipyramidal with identical atoms. The bonded atoms should not be changed. In such a case, their dipole moment is 0. Example చూడండి, linear తీసుకున్నాం అనుకోండి, the shape is linear. The better example for linear is CO2, C double bond O, C double bond O. The vector quantity, as we discussed already, this is one vector quantity and this is one vector quantity. Okay Rana, two vector quantities we have. Okay, this is in this plane, this is out of the plane. Two planes becomes 0. One vector quantity can nullify another vector quantity. So mu equal to 0. Not even this one, XEF2, same linear, XEF2. This is in this plane, this is in this plane. Again, dipole moment 0. Mu equal to 0. Or even you can take boron trifluoride, BF3. This is F, this is F, this is F. Trigonal planar, right? This is vector quantity, this is vector, this is vector. Okay, Rana? So the resulting vector equal to 0. Or even XEF4, square planar. This is in this way, same Nana. In this way, So resulting the vector quantity becomes 0 because it is shape is square planar. This is the shape of this molecule, trigonal planar. These two are linear. Trigonal planar, square planar and all linear molecules Even all regular geometry means like CH4. What is the geometry? Tetrahedral, right? For tetrahedral molecules also, dipole moment 0, mu equal to 0. Rasara? Right. The next one. Then which molecules becomes polar, Nana? Mu E is not equal to 0. Means polar. Which molecules becomes polar? See. All irregular geometry. Irregular geometry means like angular shape or even pyramidal shape, yes, or even seesaw, these are all irregular geometry. For them, dipole moment is not equal to 0. Dipole moment is not equal to 0. Example chonana, like H2O. What is the shape it has? Angular shape. This is vector quantity, this is vector quantity. They are merging. Both are present in same plane. The resulting vector is something value. So, dipole moment is not equal to 0. Okay. Then now coming for the NH3. Nitrogen, hydrogen, hydrogen. In this plane, in this plane, in this plane. So, dipole moment is not equal to 0. Not even this one, many examples we have. SF4, seesaw. Dipole moment is not equal to 0. Any irregular geometry. Okay. I will give some other examples. For mu equal to 0, if examples ra. BCl3, CO2, okay, SF6, PCl5, CH4, CCl4, etc. For mu is not equal to 0, irregular shapes, H2O, NH3, NCl3, okay, CHCl3, because identical atoms are not there, different atoms. Even the shape is tetrahedral, but different atoms are there. Here the shape is tetrahedral with identical atoms. Okay. Or even HF, HCl, SF4, ICl3, because T shape, etc. వీటికి ఇంకా ఉంటాయి mu equal to 0 కి like XCF2 linear, XCF4 square planar. Right on. చెప్తా. నెక్స్ట్ వన్ చూడండి, కంపారిజన్ ఆఫ్ డైపోల్ మూమెంట్స్. సెకండ్ వన్, కంపారిజన్ ఆఫ్ డైపోల్ మూమెంట్స్. సెకండ్ అప్లికేషన్, కంపారిజన్ ఆఫ్ dipole moments. If you compare dipole moment of NH3 with NF3, we have NH3 ni NF3 తో కంపేర్ చేసాడు అనుకున్నాను. Which has more? Both have dipole moment is not equal to 0. This is also not equal to 0. This is also not equal to 0 because both have pyramidal in shape. ఏ షేప్ లో ఉంటాయి? pyramidal in shape. But which has more dipole moment between ammonia and nitrogen trifluoride? Ammonia has more because this is the lone pair present in this direction. Bond pairs vectors also present in the lone pair vector because nitrogen is more electronegative than hydrogen. While coming for the NF3, the fluorine has more electronegative than hydrogen. So that is the reason the lone pair bond pair is present in opposite plane. The lone pair and bond pair is present in opposite plane. So that is the reason dipole moment of NH3 greater than NF3. The reason behind it, in NF3 the lone pair and bond pair in the opposite plane. ఏ plane లో ఉన్నాయి? opposite plane. Opposite plane. That is the first thing, comparison. Second one, HF, HCl, HBr, HI. దేనికి ఎక్కువ ఉండదమ్మా డైపోల్ మూమెంట్? HF greater than, because more electronegativity. HF greater than, HCl greater than, HBr greater than, HI. ఇదే CH3F ఇచ్చి CH3Cl, CH3F, CH3Br, CH3I ఇచ్చాడు అనుకోండి, ఎవరికి ఎక్కువ ఉండదు? CH3Cl greater than, CH3F greater than, CH3Br greater than, CH3I. You are going to do certain mistake over here. మీరు అలా రాయొద్దు, ఓకేనా? స్టార్స్ పెట్టుకోండి, మీరు చేసే తప్పు అనమాట ఇక్కడ. Why we are going to find CH3Cl more than CH3F? The only reason, fluorine has small in size. చిన్న సైజ్ ఉంటుంది కాబట్టి ఇంటర్ ఎలక్ట్రాన్ repulsions are dominating, so that it cannot attract strongly the electron pair from carbon atom. కార్బన్ ఆటమ్స్ నుంచి స్ట్రాంగ్గా ఎలక్ట్రాన్ పేర్ తీసుకోదు. రీజన్ ఏంటంటే చూడండి, ఇక్కడ హెచ్ఎఫ్లో హైడ్రోజన్ డజంట్ కంటైన్ ఎనీ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్స్ ఆర్ బాండ్ పేర్ ఆఫ్ ఎలక్ట్రాన్స్. సో దట్ ఈస్ ద రీజన్ దిస్ పేర్ ఆఫ్ ఎలక్ట్రాన్స్ ఆర్ స్ట్రాంగ్లీ అట్రాక్టెడ్. బట్ ఇన్ ద కేస్ ఆఫ్ CH3F we have 3 bond pairs. అంతేనా? If this pair of electrons are strongly attracted, fluorine has already 6 lone pair of electrons. Then if this is closely attracted, then what will happen? There is somewhat repulsions between the electron pairs. So that is the reason the fluorine does not attract the pair of electrons from carbon strongly. అర్థమైందా? ఇక్కడ ఫ్లోరిన్కి ఒకే ఒక ఎలక్ట్రాన్ పేర్ తీసుకుంటుంది. బట్ ఇన్ దిస్ కేస్ ఇఫ్ దిస్ పేర్ ఆఫ్ ఎలక్ట్రాన్స్ ఆర్ స్ట్రాంగ్లీ అట్రాక్టెడ్, దెన్ వాట్ విల్ హ్యాపెన్? ద pair bond pair of electrons are there between carbon and hydrogen. Even these pair of electrons are also coming close to the fluorine. As fluorine already have 3 lone pair of electrons, then which can increase inter electron repulsions. Energy increases, stability decreases. So that is the reason it could not attract చేయదు. ఓకే, అది ఒక డాక్టర్ రాయండి. The reason behind it, small in size. Which has small in size? Fluorine has small in size. Next one. Rasara. In polyhalogens, how does the dipole moment changes? In polyhalogens, like let me take CH3Cl. CH3Cl greater than CH2Cl2 greater than CHCl3 greater than CH4 equal to CCl4, dipole moment 0. For these three molecules, dipole moment is not equal to 0. Means dipole moment decreases with increase in number of chlorine atoms. ఎందుకు సార్ అంటే ఇలా ఉంటుంది. కార్బన్ హైడ్రోజన్ బాండ్ ఈజ్ ఇలా ఉంటుంది వెక్టర్ క్వాంటిటీ. But while coming for the carbon and chlorine, opposite direction. As number of chlorine atoms increases, opposite direction increases. So dipole moment decreases. Write down. Next. As angle of separation increases, angle of separation increases, dipole moment decreases. చూడమ్మా, దిస్ ఈజ్ క్లోరో ఆర్థో డైక్లోరోబెంజిన్, మెటా డైక్లోరోబెంజిన్, దిస్ ఈజ్ para డైక్లోరోబెంజిన్. ఓకే, the vector quantity like this. Okay, vector quantity like this. So which has more dipole moment? Right, angle of separation increases, dipole moment decreases. Here bond angle is 60 degrees, 120 degrees. Here 180 degrees. Which has more dipole moment? Ortho greater than, meta greater than, para. For para, dipole moment is 0. That means for this dipole moment is not equal to 0. For this not equal to 0. For para, dipole moment equal to 0. Because both are present in opposite plane. Exactly present in opposite plane, like linear. చూసుకోండి ఇంకో కాజు. ఇలా పెరా మాలిక్యూల్స్ ఉన్నాయనుకోండి అన్న, ఇది ఎక్స్ అందాం, ఇది ఎక్స్ అందాం. ఇఫ్ ఎక్స్ ఈక్వల్ టు హ్యాలోజన్స్, క్లోరిన్, బ్రోమిన్, ఫ్లోరిన్, అయోడిన్ ఇవి ఉన్న సైనైడ్ సిఎన్ గ్రూప్ ఉన్న, ఫర్ దట్ డైపోల్ మూమెంట్ ఈక్వల్ టు 0. ఓకే, ఇఫ్ ఎక్స్ ఈక్వల్ టు OH, SH, NH2, NR2. ఓకే, ఇవే కాదురా, CHO ఉన్న, COOH ఉన్న డైపోల్ మూమెంట్ 0 అయింది. ఈ గ్రూప్స్ ఉండేటప్పుడు ఏమవుతుందంటే డైపోల్ మూమెంట్ ఈజ్ నాట్ ఈక్వల్ టు 0 బికాస్ దే హ్యావ్ bent and pyramidal shape, but they have trigonal planar or linear shape. So dipole moment is 0. Okay na? Right, next one. For cis and trans compounds, comparison with similar groups. C double bond C, CH3, CH3, H, H. What kind of compound it is? Cis-A. If two identical groups are present in opposite plane is called trans. This is the vector quantity in this plane. This is the vector quantity in this plane. Both are opposite direction. So both are opposite direction means for trans molecules dipole moment is 0, which is non-polar, which is non-polar. While we have cis, C double bond C, CH3, H, H, CH3. Both methyl groups are present in same side, means both vector quantities are present in within the same plane. Same plane means the vectors are merging. Merging means for cis dipole moment is not equal to 0, which is polar. కాబట్టి ఏమైందంటే బాయిలింగ్ పాయింట్ ఆఫ్ cis is greater than trans, because polar molecules dipole interactions are present, more boiling point. While coming for the melting point is trans is greater than cis. Trans is greater than cis. The last application, based on dipole moment, we are going to calculate percentage of ionic character in a given covalent compound, that equal to mu observed by mu calculated into 100. Formula for percentage of ionic character. We can find polarity, we can find electronegativity, and we can find geometry. And besides all these, we can find percentage of ionic character. Mu calculated అంటే ఏంటి? Charge into distance of separation. చెప్పాం కదా ఫార్ములా. That means percentage of ionic character equal to mu observed by charge into distance of separation into 100. ఓకేనా? రిమైనింగ్ వీఆర్ గోయింగ్ టు డిస్కస్ ఇన్ అవర్ నెక్స్ట్ క్లాస్ రా. థ్యాంక్ యూ అన్న. రేపు అటామిక్ స్ట్రక్చర్. ఓకేనా? బాయ్ రా. మా ఆన్లైన్ స్టూడెంట్స్ బాయ్ రా.